Trials of random experiments are called Bernoulli's trial if they satisfy the following condition. Each trial has exactly two outcomes. The two outcomes may be a success or a failure, which is same for all the 6 trials. Hence, drawing a ball with replacement is a Bernoulli's trial. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now, in this session I am going to discuss regarding very important concept, that is Bernoulli's trial and binomial distribution. Bernoulli's trial as well as the binomial distribution. This is very important. In this binomial distribution, you may expect one 5 marks question for the point of examination. This is very important concept. Now let us discuss the first concept, Bernoulli's trial. Now what is the definition? Trials of random experiments are called Bernoulli's trial if they satisfy the following condition. If it satisfies the following 4 conditions. So the trials of a random experiment, any trial of a random experiment is called a binomial trial, is called the binomial trials if the following conditions are satisfied. Now, what is the first condition? There should be a finite number of trials. The number of trials must be finite. It should contain finite number of trials. And the second one is the trial should be independent. It is an independent. It should not depend upon any other. So, the trials are independent trials. Next, each trial has exactly 2 outcomes. So, each trial should have exactly 2 outcomes. The 2 outcomes may be success or failure. It may be a success or a failure. So, each trial has exactly 2 outcomes. The 2 outcomes may be a success or a failure. Now, the probability of success remains the same in each trial. In each trial, the probability of the success will remain the same. So, if all these 4 conditions are satisfied, then the trials of a random experiment are said to be Bernoulli's trials. They are called the Bernoulli's trial. Now, let me explain this concept with a small example. Let us consider, for example, throwing a die 50 times. If you throw a die 50 times, is a case of 50 Bernoulli's trial. Throwing a die 50 times is an example for is a case of 50 Bernoulli's trials, in which each trial results in success, say an even number, or a failure, say an odd number. So, the success is an even number and the failure is an odd number. So, in each trial results in success. Let us represent is, say it is an even or failure as an odd number. The probability of success is P, denoted as P, is same for all 50 throws. Obviously, the successive throws of the die are independent experiments. So, if the die is fair and have 6 numbers 1 to 6 written as 6 faces, then the probability P is equal to 1 by 6 and Q is equal to 1 minus 1 by P, that is also equal to 1 by 2. That is the probability of a failure. Right. See here. Now, let us consider an example of a die throwing 50 times is a case of 50 Bernoulli's trial. So, in which each trial results in success. Let us call it as an even number, or a failure. Let us call it as an odd number. And the probability of success is P, is same for all the 50 throws. Therefore, P is equal to 1 by 5. And obviously, the successive throws of the die are independent experiment. So, if the die is fair and have 6 numbers 1 to 6, then written on the 6 faces, the probability P is equal to 1 by 2 and Q is equal to 1 minus 1 by P, that is 1 minus 1 by 2, that is also equal to 1 by 2. So, that is nothing but the probability of a failure. Okay. Now, let us come to a small example, another example. Let us consider a problem. So, 6 balls are drawn successively from an urn containing 7 red and 9 black balls. So, there are 7 red and 9 black balls. Totally there are 16 balls An urn contains 16 balls. Let us consider another example. 6 balls are drawn. How many balls we are going to draw? 6 balls are drawn successively from an urn containing 7 red and 9 black balls. Tell whether or not the trials of drawing balls are Bernoulli's trial when after each drawn the ball is replaced and not replaced in the urn. So, with replacement and without replacement, say whether it is a Bernoulli's trial or not. This is also simple example. Now, what is the problem given? So, 6 balls are drawn successively from an urn. So, we are going to draw 6 balls successively from an urn which contains 9 black balls and 7 red balls. So, totally 16 balls. So, we have to tell whether it is a Bernoulli's trial or not. The condition is the drawn ball is replaced and not replaced in the urn. The first condition is after replacement whether it is a Bernoulli's trial or not. Before, yes, without replacement whether it is a Bernoulli's trial or not, that we have to say whether it is a Bernoulli's trial or not. Now, first, the number of trials is a finite. It is a finite trial. The first condition is satisfied. When drawing is drawn with replacement, the probability of success, say a red ball. So, we have to take a red ball. The probability of success is a red ball is P is equal to, there are 16 balls, out of which there are 7 red balls. Therefore, the probability of P is equal to 7 by 16, which is same for all the 6 trials, right? See, the number of trials is a finite trial. The first condition is satisfied. When the drawing is done with replacement, the probability of success, say getting a red ball, will remain the same. That is, probability of getting a red ball is P is equal to 7 red balls out of 16, 7 by 16, which is same for all the 6 trials. Hence, the drawing ball with replacement is a Bernoulli's trial. Okay, see. The number of trials is finite. Further, when the drawing is done with replacement, the probability of success, say getting a red ball, is 7 by 16. That is, there are 7 red balls out of 16. So, 7 by 16, which is same for all the 6 trials. Hence, drawing a ball with replacement is a Bernoulli's trial. Hence, it is a Bernoulli's trial. So, with replacement, it will form a Bernoulli's trial. Now, let us come to the second case. What is the second case? Without replacement. Without replacement. It is not replaced. Now, let us come to the second part. When the drawing is done without replacement, the probability of success, that is getting a red, in the first case is 7 by 16. Okay. Suppose if you draw a ball, getting a red ball, in the first trial is 7 by 16, and in the second trial, so without replacement, one ball is taken out. So, 7 minus 1 is 6, divided by 16 minus 1 is 15. In the second trial, it is 6 by 15. If the first ball drawn is red, 7 by red, or it is 7 by 15, then if the first ball drawn is black, and so on, clearly the probability of success is not same for all the trials. So, it is different trials. So, for the first trial it is 7 by 16 and for the second trial it is 6 by 15. So, therefore, without replacement, this will not form a Bernoulli's trial. Hence, the success is not same for all the trials. Hence, the trials are not Bernoulli's trial. Okay. So, listen here. When the drawing is done without replacement, the probability of success, that is getting a red ball, in the first case is, how many red balls are there? 7 out of 16. The first case is 7 by 16. Once if you take one ball from the urn, and what are the red, how many number of balls left are? 6 divided by 15. So, 6 by 15. In the second trial, the possibility is 6 by 15 if the first ball drawn is red, or 7 by 15. So, therefore, if the first ball drawn is black and so on, clearly the probabilities of success are different. is not same for all the trials. 7 by 16, another one is 6 by 15. Hence, the trials are not a Bernoulli's trial. So, without replacement, it is not a Bernoulli's trial, whereas with replacement, it will form a Bernoulli's trial. This is a small example for a Bernoulli's trial. Now, let us come to the next very important concept, that is called a binomial distribution. This is very important. So, you may expect one question from this 5 marks. Now, what is the definition for this binomial distribution? The probability distribution of number of success in an experiment consisting of n Bernoulli's trials may be obtained by the binomial expansion of q plus p to the power of n. So, the probability distribution of number of success in the experiment consisting of n Bernoulli's trial may be obtained by the binomial expansion of q plus p plus q to the power of n. Hence, this distribution of number of success x can be written as, that is, hence the distribution of number of success of x. If x denotes the number of success, then the distribution of number of success of x can be denoted as x and p of x. When x is equal to 0, 1, 2, 3, etc. up to n, then probability of x is equal to, using binomial theorem, nc0 q to the power of n into nc1 q to the power of n minus 1 into p to the power of 1. Next, nc2 q to the power of n minus 2 into p2. Next, nc3 q to the power of n minus 3 into p3, etc. Number of terms, ncx q to the power of n minus x into p to the power of x, etc. Last term, ncn p to the power of n. So, therefore, this ncx q to the power of n minus x into p to the power of x is the general term in the expansion of p q plus p to the power of n. Hence, we are going to use this, the nth term, to solve the problems in this binomial distribution. The nth term or the general term is given by ncx q to the power of n minus x into p to the power of x. So, this is called the binomial distribution. Listen to me, I'll explain once again. The probability distribution of number of success in an experiment consisting of n binomial trials may be obtained by the binomial expansion of q plus p to the power of n. Binomial expansion of q plus p to the power of n. Hence, this distribution of number of success is denoted as x. So, therefore, the number of success, if x is the number of success, then the probability distribution of this is given by x is equal to 0, 1, 2, 3, 4, etc. up to n times p of x is equal to probability of success is, first term is when x is equal to 0, nc0 q to the power of n. When x is equal to 1, nc1 q to the power of n minus 1 into p to the power of 1. When x is equal to 2, nc2 q to the power of n minus 2 into p2. When x is equal to 3, nc3 q to the power of n minus 3 into p3, etc. The general term or the nth term is ncx q to the power of n minus x into p to the power of x, etc. The last term is ncn p to the power of n, is called the binomial distribution. This is called the binomial distribution. The above probability distribution is known as the binomial. That is known as the binomial distribution with the parameters n and p. This is important. The parameters are n and p, because for giving the values of n and p, we can find the complete probability distribution. Now, the probability of x success is denoted as p of x is equal to, is also denoted as p of x, and is given by p of x is equal to ncx q to the power of n minus x into p to the power of x. This is very important formula. That is, p of x is equal to ncx, p of x is equal to ncx into q to the power of n minus x into p to the power of x. So, p of x is called the probability function of the binomial distribution. This p of x is called the probability function of the binomial distribution. So, a binomial distribution with n Bernoulli trials and the probability of the success in each trial as P is denoted as B of n into P. That is the binomial distribution. B of n into P is called the binomial distribution of n Bernoulli trials, and the probability of success in each case is P is denoted as B of n comma P. So let us consider a small example. Now this is very important example as well as very important problem for 5 marks. You may expect this, at least in the examination they may ask 1 or 2 cases. They may ask first and second, otherwise first and last. Now if a fair coin is tossed 10 times, how many times? 10 times, n is equal to 10. A fair coin is tossed 10 times, find the probability of, what are the condition? Exactly 6 heads, at least 6 head, at most 6 head. So a fair coin is tossed 10 times, here n is equal to 10. Find the probability of exactly 6 heads, at least 6 heads, at most 6 heads. Now let us come to the solution. What is the solution? The repeated toss of a coin are called the Bernoulli trial. Hence, X denote the number of heads in an experiment of 10 trials. So, therefore, n is equal to 10 and P is equal to 1 by 2. So, getting 1 head after 2 events, 1 head divided by 2 events. So, here n is equal to 10 and P is equal to 1 by 2. Whereas Q not getting an head, Q is equal to 1 minus P, that is 1 minus 1 by 2. This is also equal to 1 by 2. So, Q is also equal to 1 by 2. So, P is equal to 1 by 2 and Q is equal to 1 by 2 and N is equal to 10. Now, since we know the formula for this, P of x is equal to, what is the formula? NCX Q to the power of n minus x into P to the power of x. NCX Q to the power of n minus x into P to the power of x. Now substitute the values. P of x is equal to, here P of x, what is n? N is equal to 10 Cx. What is Q? Q is equal to 1 by 2 to the power of 10 minus x. Again P is also equal to 1 by 2 to the power of x. So this can be written as 10 Cx. Using law of indices, 1 by 2 to the power of 10 minus x into 1 by 2 to the power of x can be written as 1 by 2 to the power of 10 minus x plus x. These two gets cancelled. This is equal to 10 Cx 1 by 2 to the power of 10. So this is the general formula for this. So P of x is equal to 10 Cx 1 by 2 to the power of 10. Now, using this, just substitute the value of x, exactly 6, x at least 6 head and at most 6 head. So, here 3 cases are given. Now, listen to me here, I will explain once again. A fair coin is tossed 10 times, find the probability of exactly 6 heads, at least 6 head or at most 6 head. Now, the repeated toss of a coin or Bernoulli trial, let us represent x as an event. Let x depends the number of heads in an experiment. So here given, what is given? Number of trials n is equal to 10, P is equal to 1 by 2 and Q is equal to 1 minus 1 by P is equal to 1 by 2 itself. So P is equal to 1 by 2 and Q is equal to 1 by 2. Now, since we know using binomial distribution, by P of x is equal to NCX Q to the power of n minus x into P to the power of x. P of x is equal to n is 10 Cx, Q is 1 by 2 to the power of 10 minus x and P is again 1 by 2 to the power of x. This can be written as 10 Cx 1 by 2 to the power of 10 minus x plus x, minus x plus x gets cancelled, 10 Cx into 1 by 2 to the power of 10. Okay. So hence, therefore, probability of x is equal to, what is the answer we got? 10 Cx 1 by 2 to the power of 10 Cx 1 by 2 to the power of 10. Now, come to the first case. What is the first case? probability of x is equal to 6, that is exactly 6 head. Exactly 6 head means P of x is equal to 6. So here P of x is equal to 6 is given by exactly 6 head. So that is 10c x is equal to 6 into 1 by 2 to the power of 10. Now you know the formula for NCR is equal to factorial n divided by factorial r into n minus r. So 10c6 can be written as factorial 10 divided by factorial 6 into 10 minus 6 is factorial 4. This is nothing but 10 into 9 into 8 into 7 into factorial 6 divided by factorial 6 into 4 into 3 into 2 into 1. Factorial 6 gets cancelled. So this is 4 2s are 8 gets cancelled, 3 3s are 9 gets cancelled. What is remaining here? This is equal to 10 into 3 into 7. 10 into 3 into 7. So this is equal to 10 into 7 3s are 21. So this is 10 into 21 is 210. So therefore this is P of x is equal to 10c6 1 by 2 to the power of this can be written as this is 10c6 is equal to 210 into 1 divided by 2 to the power of 10. This is 210 into 1 by 210 into 1 divided by 2 to the power of 10. Since if we multiply 2 10 times, we are going to get it as 1 divided by 1024, 1024. Now divide by 2. If you divide by 2, you will get 105 divided by this is 512. So hence P of x, therefore probability of x is equal to 6 is 105 divided by 512. So 105 by 512, that is exactly 6 x is 105 divided by 512. This is the first answer. Okay, hope you followed this. Now the second case is at least 6 heads. At least 6 heads. Now let us come to the next page. At least 6 heads means probability of x is greater than or equal to 6. That is probability of x is equal to 6 plus probability of greater than 6 means 7 plus probability of x is equal to 8 plus probability of x is equal to 9 plus probability of x is equal to 10. 10 times we are tossing. Okay. So x is equal to 6, 7, 8, 9 and 10. Substitute the values and simplify, you will get the answer. That's it. Now when x is equal to 6, we will get 10c6 into 1 by 2 to the power of 10, because what is the formula here? P of x is equal to x is 10 cx into 1 by 2 to the power of 10. When x is equal to 6, 10c6 1 by 2 to the power of 10. When x is equal to 7, 10c7 1 by 2 to the power of 10. When x is equal to 8, 10c8 1 by 2 to the power of 10, it is same, plus when x is equal to 9, 10c9 1 by 2 to the power of 10, plus when x is equal to 10, 10c10 1 by 2 to the power of 10. So if we remove 1 by 2 to the power of 10 common factor and simplify, 10c6 plus 10c7 plus 10c8 plus 10c9 plus 10c10 is nothing but 1. So this is equal to, if you simplify this, the answer you are going to get is 193 divided by 512. So therefore probability of x greater than or equal to 6 is 193 divided by 512. That's it. This is for the second case is concerned. Okay, hope you followed. Now listen to me, I will explain. Second case, probability of at least 6 heads. At least 6 heads means there must be 6 8s and greater than 6. So therefore P of x is greater than or equal to 6. P of x is greater than or equal to 6 means probability of x is equal to 6 plus probability of x is equal to 7 plus probability of x is equal to 8 plus probability of x is equal to 9 plus probability of x is equal to 10, because there are 10 trials. Now this is the general formula we got from the previous one is 10cx into 1 by 2 to the power of 10. So this is 10 for x is equal to 6, 10c6 1 by 2 to the power of 10. For x is equal to 7, 10c7 1 by 2 to the power of 10. When x is equal to 8, 10c8 1 by 2 to the power of 10 plus 10c9 1 by 2 to the power of 10 plus 10c10 1 by 2 to the power of 10. You can take 1 by 2 to the power of 10 as the common factor. What are the terms remaining? 10c6, 10c7 plus 10c8, 10c9, 10c1, 10c10 is 1. So after simplifying this, we are going to get 193 divided by 512. Hence the probability of x is greater than or equal to 6 is 193 divided by 512. This is for the second case is concerned. Now let us come to the case 3. What is case 3? At most 6 heads. At most 6 head means probability of x less than or equal to 6. So therefore that is probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4 plus probability of x is equal to 5 plus probability of x is equal to 6. So we know P of x is equal to x is 10cx into 1 by 2 to the power of 10. Substitute the value. So this is equal to probability of x is equal to 0 means 10c0 into 1 by 2 to the power of 10 plus probability of x is equal to 1 means 10c1 into 1 by 2 to the power of 10 plus when x is equal to 2 means 10c2 1 by 2 to the power of 10 plus 10c3 means, yes, when x is equal to 3 means it is 10c3 1 by 2 to the power of 10 plus when x is equal to 4 this is 10c4 1 by 2 to the power of 10. When x is equal to 5, 10c5 1 by 2 to the power of 10 and the last term is 10c6 1 by 2 to the power of 10. So this is equal to, so you can take the common factor. What is the common factor here? 1 by 2 to the power of 10 and simplifying 10c0 plus 10c1 plus 10c2 plus 10c3 plus 10c4 plus 10c5 plus 10c6. So after simplification, so we are going to get it as, so after simplification, so you are going to get it as, this is 1024 into this is 848, 848, okay. So 848 divided by 1024, so this is 848 divided by 1024. So if you divide by 16, this is equal to 53 divided by 64. 53 divided by 64 is the required answer. So therefore the probability of x less than or equal to 6 is 53 divided by 64. So this is the required answer. Followed? See here. So therefore x is greater than 6, 193 by 512. So 193 divided by 512 for the first case, and for the last case it is, what is the answer we got? 53 divided by 64. 53 divided by 64. So this is the required answer. Probability of at most 6 heads is P of x is less than or equal to 6 is equal to 53 divided by 64. Okay. Anyway, this is very important problem. We may get at least first and second case or one case for 3 marks, first and second case for 2 marks. Okay. So that's all regarding today's session. Let us meet with different problems in the next class. Thank you very much.